We're going to be going over some basics in how to use the line optimization and poll worker management tool that was developed by Steve Graves and Rong Yuan. We'll focus on the right-hand side of the web screen, the side that has entered data at the very top. Notice that we can choose whether to do the exercise in terms of checking in, which is the default, or whether we want to allocate voting machines. In this video, we'll choose the check-in process, but everything applies in the same way if we're doing the analysis in terms of voting machines. Right below the toggle for check-in and voting machines is a little table which allows us to enter the data. There are 6 columns in this table: the name or number of the precinct, the arrival rate of voters on a per hourly basis, the average check-in time, which is given in minutes, the number of check-in stations at the precinct, the maximum wait time target, and the service level, which we'll talk about in just a second. Notice the blue Calculate button below the data entry table. Below that is a table labeled Results, where, not surprisingly, results will be displayed once we've entered the data. Back up towards the top of the screen, there is a button which says Add Precinct. If we want to enter data, we click on this Add Precinct button, which now adds a row to the table in the Enter Data section. We're ready for data entry. Let's take a very simple example. To add some meat to this example, I will assume that the voting day is 12 hours long and that we expect 660 people to show up to vote. That works out to an average of 55 voters per hour. In addition, I will assume that we have estimated that it takes an average of 1 minute to check in. We'll call this precinct number 1. I'll click over on the arrival rate cell. Because we've already calculated that the average arrival rate during the day is 55 voters per hour, I will enter the number 55 into this box. And because we have estimated that it takes 1 minute to check in, I will click on the next box and type in the number 1. In this example, let's start by allocating 1 poll book or check-in station to the precinct. We'll enter that number in the next box under the heading that reads Number of Check-in Stations. The next column, labeled Maximum Wait Time Target, allows us to specify what we would consider to be the longest acceptable wait time to check in. The Presidential Commission on Election Administration recommended that everyone should be able to vote with no more than a 30-minute wait. We'll enter 30 into this box. The last column allows us to specify how tolerant we would be if it takes voters longer to check in than our maximum wait time target. For example, if we're trying very hard to meet the target we've set, we might decide we will only be satisfied if 95% of voters wait less than our maximum wait time target. That would mean that when we plan, we would tolerate up to 5% of voters waiting longer than 30 minutes. As you'll see later on, if the program calculates that more voters will wait longer than your maximum wait time target, it will also give you guidance about how to correct the situation. To move on, I will enter 95 into the final box. With all the data entered, I can now click Calculate, and we see the results populate the results table down below. Looking at the results table, we see the following reported for Precinct 1. The average wait time to check in would be 11 minutes. The third column indicates that 7.5% of voters would wait longer than the 30-minute maximum wait time target we had specified above. Finally, look at the results under the heading that reads Number of check-in stations required to meet the service level. The number 2 is reported there. That means that if we want no more than 5% of our voters to wait more than 30 minutes to check in, we need to have 2 check-in stations at the precinct rather than 1. We can illustrate what would happen if we were to follow this advice by going back up to the data table, to the box where we indicate the number of check-in stations. I can enter in the number 2 up there. I click Calculate again, and it tells me that now with 2 check-in stations, the average wait time goes down to 0.3 of a minute. That's 18 seconds, and that nobody would wait longer than the 30-minute maximum wait time target. Now, before finishing, we should say a word about the values that are allowable in the upper part of the tool where we enter our data. Precinct can be a number or even text. For instance, when I type in the word north and click calculate, you'll notice that the word north is repeated down in the results. I have entered the average arrival rate as an integer, but you can also enter a decimal amount if that added precision will help. For instance, if we had estimated that the arrival rate of voters throughout the day was 50.5 voters per hour, then we could enter that in and also calculate wait times based on a decimal arrival rate of voters. Similarly, we can enter in the check-in time as a fractional number of minutes. For instance, if instead of taking 1 minute to check in to vote, say it takes 30 seconds on average. Remember that 30 seconds is half of a minute, or 0.5 minutes. We can enter 0.5 minutes in the box, hit calculate, and get the results. The number of check-in stations, of course, needs to be an integer. Don't enter in a fractional number there. The maximum wait time target can similarly be a decimal. For instance, if we set the maximum wait time target to 30.5 minutes and hit calculate, we get sensible results. Similarly, we can enter a decimal in the service level percentage box. One final thing. If you have several precincts to analyze, you can also click on the Add Precinct button at the top again and get a second row in the data entry field. The second precinct might have a different set of values from the first. I can just add those, then click Calculate, and now we get results for 2 precincts.